on routing technologies. So last time we have the overview of the virtual local area network. So we start. So for this, I want you to respond if you would like to have the recording for this lecture, and this would be published in YouTube. Okay. So just say yes or write on the Google Classroom chat message. Okay, thank you for your reply. So we will start the lecture on routing technologies. So this would be just 42 slides. So it's not going to be more than. So now we are almost 70% going to finish our lecture. So we'll just have the summary of this, and since I already provide you with the recording, so the questions will be after the lecture summary. So lesson 6 is composed of Lesson 6 is composed of routing technologies. So this would discuss the importance of routers in broadcast domain, router interfaces, router tables, router protocols, access control units, and open short path first. And also we have enhanced interior gateway routing protocols. And for this, in addition for dividing the large network, so uh, in order for us to provide routers, so we need to divide each network. And with this, we use router, and this would create a complex internetwork so that local area network in large international corporation can communicate efficiently. So this is the reason why we need uh, to divide large networks. As you know, routers operate in network layer 3 and and work with packets as a protocol data unit. These devices, packet data unit, and these advanced devices connect separate logical networks to form internetwork. And a router can be used to facilitate exchanging data between networks, but broadcast frames are kept in their respective networks. So the internet uses routers to interconnect thousands of networks around the world. So routers are also used to control network access by inspecting source and destination address. So information of packets they handle. So based on the rules, an administrator defines a router can forward a packet or discard it. So we have the features, we have router interfaces, routing tables, router protocols, and access control lists. So what are router interfaces? So these are the ports that takes a packet coming from one network. So these are packet data unit. So each interface on a router has a full layer 3 functionality. So meaning it can receive and transmit data, PDU. And it will include the internet protocol address and the physical address. In fact, you can look at the router interface just as a network interface card with the internet protocol bound to it. So when a router interface receives a frame, It performs a data link layer function and comparing the destination physical address with the interface physical address if they are matched. So the router reads the frame and strip the frame header and trailer. So the header will provide you the IP address and the trailer will contain the data. So if they don't match, the router discards the frame and the next router checks the resulting packet's destination address. So if the address matches the IP address of the interface, so on which the packet was received, the packet was intended to the router, which simply processes the packet. So if the destination or internet protocol address network ID doesn't match the interface address network ID, so the router knows the packet should be routed to another network. So later I will have an example. This is using Cisco Packet Tracer, and I will provide you the file for you to practice at home or in your mobile. So, okay, can you see the packet tracer that I have? Any reply from this class? Can you see? Okay, correct. So, for example, this is the network that I made based on your assignment last time. So what happened is, so I divide each network into different locations. So example, we have gym, auditorium, office, student hall. So in the gym, you have 140 magnifier. Okay, very small. I think there is. Ah, I think here. Okay, so for example, I provide this number of computers or connections in a certain location. So for this first location, you will have 140 computers. Next, we have 90 connections, and this is 52, and the last is 24. Now, for this location, how will you determine the number of connections? So what will happen is, since you start your count from two to the first, so since 1 to 8 is not enough, so you'll go to another uh, number of bits. So since 2 to the n is the formula, so since 1 to 8 is not enough for 140, so you go with 2 to the 8, which is 256. So you have an excess of other you have an excess of more than 140 networks here in why we need to use 256. So because your if your division, if you could provide more connection, much better, because in every year, so the subscribers or the consumer are also increasing. So that's why it's better to have more than 140 allocation for each area. Now, for auditorium, so you limit only to 90. So you will have 2 to the 7. So that is 1 to 8. And this one, this is the formula for your number of usable IP addresses. So take note, you will only use 254 because the two IP address here are given to the network number and your broadcast address. So that's why we subtract 2. So this is only the usable IP addresses that you could use at the same time with other scenarios. Okay. So for office, so you have 52. So the maximum IP address you could use is 62, and student hall you have 30. Now after you made this calculation, now you go to determine your CEDAR notation. Now, since we know what is the maximum bits we have in class class A, or so the maximum bits we will have in IP version 4. So the maximum bits that we could have is 32 bit. So if you subtract n, which is 8 for the gym, so you'll have CEDAR 24. Now you need to add this to your subnet mask, and this would allow you to uh, put your variable LAN subnet mask. So each department or location will have its own subnet mask number or CEDAR notation. Now you could start identifying the number of IP address. So you start your count for this from uh, this is your network number, and this would be the start of your using this. You could use this for your first IP address and until 254 for this. And for your subnet mask, so since you're using class C, so you'll have this subnet mask. And for the next, you have auditorium. So since you are net and 2 to the n, so 7, so you have this. And so you have CEDAR notation 25. And also you start your count from another address. So you have the uh, 2.1 to 2.126. So this is based on the calculation. So you're not just guessing the number of IP addresses that you're going to use, but you need to calculate. At the same time, with similar with this one, so you will also use this scenario, and until you reach the last last allocation on student hall. So what have you noticed on this example is that so each computer has a distinct CEDAR notation that is variable. So since we are going to use the network efficiently, so we need to allocate a specific IP address to one another. Now, so in establishing your first network, so you will have to create this scenario. So this is a serial connection. So meaning this could be wireless from one point to another, and this is switch, which is used to connect to several computer. Likewise, so if we have, for example, 140 computers, so this represents one computer for 140 connection. But in this example, you will have only one IP address on this because you have only one computer, but you could add more for this. You could add more switches. So since this is not enough, so this is just like how many 24 ports. So if you want to have like 140, so you need to add more ports here. I mean, you need to add more switches so that you could use the numbers of allocated numbers for computer using variable length subnet mask. Also, this is the router, which provides you communication between one switch to another switch. And also this allows you to connect to another router, even if it is too far from each other. So example, how do we simulate? So first we go to simulation. You could try to change the settings if you want to, but normally, so we will put a PDU from which, so if you want to put PDU, so example, this is a PDU, and if you want to communicate this one to another computer, so sorry. So if you want to connect this one to this one, so we'll try this. Okay, so how do we start? So by pressing play. So if you're going to deliver a packet of information to another computer, meaning it should be checked. Now, if you are not able to send it on the user, there will be X. If the packet data unit is red, meaning or there's a fire on it, meaning there's a delay or there's something wrong with the uh, or there's wrong on something you set up. So that's why it's not going to work. Like this one, so meaning router one, when you see an X, it's not connected to the other uh, computer. But if you see a check mark, meaning there is already connection. So in that case, you need to troubleshoot if you found out that there is some problem with this. And this would help you making your own project. So not just copy your friend's work, but also you need to try to express what you really want to in this type of lecture. And when you say a check mark, that is a good sign that your design is way better. And you see the screen. Okay, so we go back to oh my, again, stop. Can you see the screen? This one, okay? So what will happen is, example, what I'm saying, if you're going to press simulation, you click on this side and you need to play. So this example will help you analyze how data or packet data unit is being transferred to another computer. So if the data will move to another computer by using switch, router, and passing your data to another router and switch, and the switch will forward the data to the user. So if you see a check mark, meaning there is no problem with the sending of the data, but if you see a cross mark, meaning there is a problem in sending that data, or the data or the information was lost. So for this scenario, you receive this information, so you need to really to look into it that there's no mistake on going to the next location, because this is just like establishing your network. So so this is likewise similar to your project, but this is not that complicated uh, for the project. Now let's see your groupings, and we will try to divide each group now so that we will start with the project as soon as possible. So we have, okay. So we will assign now for your project. So I have seen that there are 5 groups in okay, for the first group or section C. So what you're going to do is you will be able to simulate this example. So this example based on the virtual LAN. So I will going to assign this to group. This is going to be group 1 for section C. So this is for group 1 section C. So save as. And I assign this to. Now for group. Now for the group 1, section B, section D. So you have Meraki. So this is for group. So this group 1, section B. Now for group 2, so you have for group 2, section C. So you have this. So for the next one, you have this. So this is group 2, 3D. So the other would be 3A. Now for the next, try to check this. No, this IP version 6. Okay, for group 3, section PC. So you have this example. Now for other group, so I'll try to check. Okay, so this is for group 3, section D. As you can see, if you have a wireless, so that would be the symbol for wireless connection if you are already connected to the gateway. So now we move to another, and we will have group 4. So I will have another sample. So we'll try Linksys, it's very common. So we have a server open. Okay, so we have this. So we have this for group 4, section C. Okay, so we have another example. Getting a voice over IP. So now this would be for the group. So we have voice over IP. So this is good for 3D group 4. 3D. Okay, we'll try this. So there's already on this similar. Okay, so this is an example of a virtual private network. So this is for the section. So we are finished with section D. So this would be on section C. Right. Now, if there will be other students who wants to form a group, so I'll give a spare project for you to do. Maybe this one should be easier. Okay, so this is for the sixth. So any questions with your project? So I give additional spare activity. So we have one, two, three, 4, 5. Okay. So we go back now to our presentation and stop sharing this. I'm going to cut the video and have a new recording.